All right, so section 10.9, 2.9, inverse function. We're basically going to try to figure out inverses to functions that are given to us. Now, what is an inverse? Well, an inverse is a mirror reflection of the original function based on the y equal to x axis. Okay, I know that sounds kind of weird. That's why I want to use Desmos. I put it right there to kind of show you what I'm talking about. So it's kind of like a mirror reflection on a diagonal axis. Okay, y equal to x. But that's what an inverse function is. How do I find an inverse function? Well, it could be 3 or 4 steps. The first thing you're supposed to change f of x to y. So if they give you a function like f of x equals to x plus 2, you're supposed to write it y equals to x plus 2. Okay? Then secondly, you're going to rewrite y to x and x to y. I mean literally erase your y, put x, and then literally erase your x that was given and you change it to y. So you're literally rewriting it. Okay? You're not moving them around or anything. You're just going to rewrite it. And then third step, you're going to solve for y, wherever it happens to be now. And then once you solve for y, for step 4, change that to f inverse of x. So it kind of looks like f to the negative 1 power of x. That means f inverse of x. Okay? And then a really quick FYI for you guys at the very bottom. It says, note the inverse of y equals to x is y equals to x. So if they ever tell you, like, find the inverse to y equals x, you're just going to write y equals x. If they say find the inverse to f of x equals x, you write f of x equals x. Okay? So that's an inverse to itself. Okay? But everything else will have a different looking at. So, again, it's going to take us 4 different steps. They don't take very long. Okay? And then we'll kind of graph each one on Desmos just so you can see what I'm talking about by a mirror reflection. Okay? So, here we go. So, we have 4 of these that we're going to do. Okay? So, we're going to find the inverse of these functions. The first one is y equals to 2x plus 1. We're just going to find the inverse of the functions. So they give us y equals 2x plus 1, and I think about the 4 steps that I'm supposed to do. Step number 1 is change f of x to y, and I said that's optional. Notice there is no f of x there. So it's already y. Okay, y equals 2x plus 1. So step 1, unnecessary. Step 2, change x to y and y to x, right? Rewrite them. So what I'm going to literally do is instead of a y in the beginning, I'm going to put an x. And then 2, and then I see an x there, I'm going to change it to y plus 1. That's step 2 right there. Very easy. Just literally rewrite them. Okay, you like erase and rewrite if you want. So instead of y equals to 2x plus 1, I have x equals to 2y plus 1. Step 3, solve for y. Okay, so I'm going to have to move the positive 1 over here. So that gives me x minus 1 equals to 2y. And then I'm going to divide everything by 2. Okay, so if I divide everything by 2, this is what I get. Well, it's x over 2, but if you guys don't mind, I'm going to write it as half x minus half equals to y. Okay, so that's step 3. Step 3 says solve for y. So there you go, I just solved for y. And then they say, okay, rewrite it so that instead of y, it says f inverse of x. So I'm going to write f inverse of x is equal to half x minus half. And let me go check it on Desmos. Okay, let me check this thing on Desmos. So my original function is 2x plus 1. And my inverse function is half x minus half. Okay? So I'm going to go over to Desmos. So notice I already graphed the y equal to x axis. Okay? I already graphed the part that it's doing a mirror image of itself. Okay? So I'm just putting that there just as a way for us to judge. Now, one of the equations was y equal to 2x plus 1. Okay, so there you go. The other equation was f inverse of x. I'm just going to write y equals half x, whoops, not there, half x minus half. You see what I mean by they're inverses of each other? Like it kind of looks like they, I don't know if it's going to show up. Yeah, I don't know if you can see my pen right here, right? Like up front. But notice how it kind of bounces off this way and this one kind of bounces off the same way. They're kind of mirror images of each other, right? They're kind of shooting towards that little dash green line. And then on the opposite side, it looks identical, just that in black, right? So the purple line has a reflection of itself in the black line, using that dotted line as a mirror. Okay? So that's what they mean by f of x and f inverse of x are mirror images of each other. So using that green dotted line as a mirror, if you were to put that mirror right there, that's what you would see. You would see that picture. Okay? So I can verify that they look like mirror images of each other based on that picture. So I'm going to get rid of these for now. We'll use it again. Let's go back to the next question. But notice that's all you have to do. I didn't put a thing here. Let me box this up for us. But that is my answer. Okay? That's my answer. Now notice this time I did write one that says f of x equals to something. So I am going to have to do all 4 steps. But the first step, very easy. Instead of f of x, I'm just going to write y. Okay? So here we go. Y is equal to 2 minus 3x over 4. Step 1 is done. Step 2, literally rewrite y to x and x to y. So instead of y equals, I'm going to put x equals 2 minus 3, and instead of 3x, I'm going to put 3y over 4. That's step 2. Step 2 is done. The hardest step is always step 3, the solve, right? So I want to solve for y. So what do I do first? All right, we're going to multiply the 4 over to this side, okay? So that becomes 4x equals to 2 minus 3y. Now let me move that 2 over to the left side. So I'm going to subtract it. That's 4x minus 2 equals negative 3y. What's my next step? All right, so we're dividing negative 3 to everything, right? So divide negative 3, divide negative 3, divide by negative 3. So I get negative 4/3 x plus 2/3 is equal to y. That's step 3. I'm done with step 3. Step 4, rewrite y as f inverse of x. So f inverse of x is equal to negative 4/3 x plus 2/3. I'll number the steps if you guys want. Again, this was step 1. This was step 2. All of this, bless you, up to here was step 3. Okay, and then you got your step 4. You're interested, like, how did you get all 4 steps? So step 1 was to change f of x to y. Step 2 was to change your y to x and x to y. Step 3 was to solve for y. So there it is, solve for right there. And then step 4 is to change y to f inverse of x. Okay? So again, just to kind of check, let's use Desmos. So 2 minus 3x over 4. Let me write this out. So 2 minus 3x over 4. You could put y equals to if you want. I'm just going to put it, but you don't need to. So I'm looking for a mirror reflection of this thing based on that green line. Okay, so the other one was it negative 4/3 or 4/3? Negative? Okay, negative 4/3 x plus 2/3. Does that look like a mirror reflection of it based on that? Yeah, right? So okay, I'm doing well. My graphs look like they're reflecting off that line and bouncing out the same way. So that looks good. That looks good. So All right, my question is done, so we'll move on. The last one, you guys should tell me what's the answer to number 4. Y equals x, or f inverse of x is x, right? Because remember I told you the inverse of f of x equals to x is itself, in a sense, right? So, so that one's not going to take us any time at all. So basically, this is the last example. The last one is literally just a repetition, so you don't have to do anything for that. So this is our last example. Y equals to 4 minus a 3/5 x. Now again, I can skip step 1 because it's not written as f of x. Okay? So it's just y equals to 4 minus 3/5 x. Now, step 2 then. Change your y to an x and your x to a y. So I'm going to write, let me change it to that here. X equals to 4 minus 3/5 y. Okay, that's step 2. Step 3, start solving for y. So I'm going to move that 4 over to the left side by subtracting it. X minus 4 equals to negative 3/5 y. How do I move that negative 3/5 to the other side? Anybody remember? Sorry? I could divide, but that scares people whenever you divide by a fraction. Multiply by its reciprocal, right? Dividing is not wrong, by the way, just so you know. You could do that. There's nothing wrong with that. It's just going to look a little weird. So to make people feel a little bit more comfortable, let me multiply by the reciprocal. Okay? That's supposed to be the trick that they teach you many years back. So what we're going to do is we're going to multiply both sides by negative 5/3. Because when you do that, these cancel. And all you're left with is just a y over here. That's why people like to do that. And then on the left side, well, we're just going to multiply. The 5 multiplies the tops. So that's going to become negative 5x plus 20. And that the bottom 3 just stays on the bottom. So instead of dividing by a fraction, you can multiply by its reciprocal. It makes it a little cleaner. A little bit cleaner. So now I'm just going to do step 4, which is rewrite my y as an f inverse. So it's going to be f inverse of x equals to negative 5x plus 20. Yeah, plus 20 over 3. All right. So I have my function, which is 4 minus 3/5 x. I have my inverse, which is negative 5x plus 20 over 3. Okay? So let's just double check. Let's make sure this works out right. So 4 minus 3/5 x. Let me check it. So I'll erase this. I'll erase that. Y equals 4 minus 3/5 x. And then the other one was 5x. Okay, negative 5x, thank you. Plus 20 or minus 20?
Plus 20.
Plus 20. And all of that is over here. Okay. Let me see. Sorry, I should have typed it out a different way, but I can fix it. Divided by 3. There we go. And do those look like mirror reflections across that dotted line? Yeah, they do. Okay. So that feel comfortable with that. I feel like I got it right. Okay. If you're like, well, what would it look like if it's not a mirror reflection? Well, let me just get rid of a term. Do those reflect along that line? Well, look, they're not even crossing at the right place. They should be crossing right on that y equals to x dotted line, but they're not. Those aren't mirror reflections. A mirror reflection would have another little diamond up here, like right here, there would be a little diamond here, and then more like that. So that would be an example of not a mirror reflection, right? If I take out, say, this, notice those don't even show up, right? I can take out the 5 and put like a 4. So notice they're not touching in the right place. They gotta cross each other at that y equal to x line. But those aren't mirror reflections right there. So that's how you can tell if it's off. They don't look like they reflect off of each other. So do you have to use Desmos? No, you don't have to. You can just trust the math and you'll be fine. But if you want to check it using a visual method, use Desmos. So let's go to number 4. And I told you guys this in a note. I told you the inverse of f of x equal to x is itself. So all you have to do is write f inverse of x is x. And that's your answer. Okay? So if you see y equals to x, just write f inverse of x is x. Okay? So I think there's one problem in your homework that's just like that. Okay, so I'm basically giving it out for free. But that one's really easy. You don't have to do any of the steps. Okay? So yeah, so there we go. This is everything you guys had to know how to do. Let me just put a box around this one. I forgot to do that. And that's it. So let me give you your homework, and then hopefully you guys can get it done before the bell.